In our previous lecture, we discussed direct material, split the direct into price and usage, and then we split the usage into mix and yield. And then we also discussed the labor variances and split into rate and efficiency. Efficiency was further split into mix and yield. Now we're going to go to the other side now, the third component of your production cost, that is the overhead variance. Overheads are of two types: variable, that vary with the level of output, like indirect material, indirect labor, electricity, gas, water. They can be split into spending and efficiency variance. And the other types of overheads called fixed overheads, they are fixed: rent, insurance, property taxes, salaries of plant manager and plant supervisor. They are fixed. These variances, fixed one, can be split into production volume and the spending variance. So we are going to discuss these variances one by one, the one I have highlighted. So here we have them. So as you can see, total overhead variances, they can be split into four variances. We just saw that. These are the four variances we're talking about. These are the four variances: spending variance for variable, efficiency variance for variable, and then production volume variance for fixed, and spending variance for fixed. So this is your variance 1, 2, 3, and 4. So we are going to discuss them all with their formulas. We'll solve many questions that will explain the concept to a finer detail. So it says that these four variances, 2 are related to variable overheads and 2 are related to fixed overheads. Now let us discuss these one by one. Let us first discuss the variable overheads. Variable overheads are of two types. First is called the spending variance. Other is called the efficiency variance. Now, how do we calculate these? Let's see the formulas. We need to learn the formulas. Spending variance can be calculated by multiplying the actual quantity of what? Actual quantity of machine hours given in the question, or actual quantity of labor hours, and sometimes actual quantity of units produced when unit of production is used as a base in the standard costing. So yeah, remember, actual quantity of machine hours, actual quantity of labor hours, or actual units produced depending upon the information given. Gentlemen, please listen to me very carefully. This SP is the variable overhead rate. This is also called the variable overhead absorption rate, variable overhead allocation rate, variable overhead recovery rate, whatever you want to call it. This is the variable overhead rate. Remember, standard price here is the variable overhead rate if you are using the variable overhead spending variance. This is important. And this AC here, this AC is the actual cost. Actual cost, what cost? Actual variable overhead or the actual variable cost. So if you have these three things, you can calculate spending variance. Now, what does it calculate? It calculates that what our spending should have been. Our spending should have been this, but our actual spending on the variable overhead is this. And I told you, the formulas are arranged in such a way that negative variance would be adverse, positive means favorable, right? So spending variance can be calculated using this formula. We will solve it just after a little while. Now, the second formula is the variable overhead efficiency variance. How do we calculate this? SP is the same: variable overhead rate, absorption rate, recovery rate, whatever you want to calculate, allocation rate. AQ same. AQ is the actual quantity of labor hours, machine hours, or units. And SQ, now listen, LH here is the actual labor hours used. SQ would be the labor hours that you should have used. Actual labor hours, standard labor hours. Let's say if you use machine hours, how many machine hours you actually used, how many machine hours you should have used as per the standard, right? So SQ and AQ would be the difference between what you actually use for labor hour and machine hours and what you should have used for labor and machine hours. And SP is clearly the variable overhead absorption rate. Okay, now let us try to apply these questions if we could find some good question, and then we'll move on. Okay, now this appears to be a good question that we can use to grip the idea. We have just learned that variable overhead spending variance, S, is actual quantity into the standard price, that is the variable overhead rate, minus actual cost variable. Same way we just read it a little while ago. And the variable overhead efficiency variance is the how many hours you should have used minus how many hours you actually used multiplied by the variable overhead absorption rate. In this question, he just asking you variable overhead efficiency variance means this one. We will also calculate the spending so that we can, if we could find if the data is given so as to make better understanding. Okay, now what we need, let us read the question. The following data relate to tray companies' manufacturing operations. Standard direct labor hours per unit. Each unit takes in 3 standard labor hours. That's the standard allowed. I told you they will be standard given. So each unit should take 3 labor hours. That is the standard. Actual direct labor hours used were 24,500. This is the actual quantity, AQ. Now, look at this. Number of units produced. You produce 8,000 units. Okay. If you produce 8,000 units, our standards tell us that each unit should take 3 hours. That means we should have used 8,000 times 3, 24,000 labor hours. This is called standard quantity. This is called standard quantity. You should have used 24,000 labor hours, but you actually used 24,500 labor hours. So this is the standard quantity of labor hours. This is the actual quantity of labor hours, right? What else? The standard variable overhead per standard direct labor hour or the variable overhead absorption rate or allocation rate, it is SP and it is equal to $2. We got everything what we need. We got everything. As per the standards, we should have used 24,000 labor hours, but we actually used 24,500 labor hours. We used more, multiplied by the variable overhead absorption rate, which is given here $2. So if you just simplify this, you will see it's going to be a negative number. 24,000 less 24,500 multiplied by 2, it's 1,000 and it's negative. So it's 1,000 adverse, so that makes B to be the correct option. We got our answer, but let us do the other part also for some good understanding. Let us calculate the spending variance. Actual quantity of hours we used for the labor were 24,500. Okay. What is the standard price or what you call the variable overhead absorption rate? That is $2, right? So as per this formula, our spending should be 24,500 multiplied by 2. Our spending should have been 49,000, right? But our actual spending given here, actual variable overhead, actual variable cost was 46,000. That is good. That is good. Our cost should have been 49,000 variable overhead cost, but it was 46,000, which means it is 3,000 plus. It is 3,000 favorable. So this part here is given, but this is not the efficiency variance. This is the variable overhead spending variance. And this one, which we calculated above, this is the variable overhead efficiency variance, right? So right now what the question says, we need to go for 1,000 because this is our efficiency variance. This 3,000, this is basically what you call the variable overhead spending variance. This is not required, right? This was the variable overhead spending variance. It's not needed in this question. All right. We just learned how to calculate the variable overhead spending variance, and we also learned how to calculate the variable overhead efficiency variance. So this is the first part done. First part of what? First part of this complete picture, as I said, this is done, this part. Now we are going to discuss the fixed overhead variances. There are two types of fixed overhead variances, production volume variance and the spending variance. Let's do that. The fixed overhead variance are split into the fixed overhead spending variance. This will give you how much fixed overhead we should have spent and what is the actual cost. And the production volume variance, this variance shows that how many units we plan to produce Let's say we plan to produce 10,000, but we produce more, maybe 12,000, or maybe we produce less, maybe 7,000. So this is the original volume we planned. Sometimes we might produce more, sometimes we might produce less. This difference in our volume, or maybe let's say if we plan to use 10,000 machine hours, but we actually used 12,000 machine hours, or maybe we actually used 7,000 machine hours. So whatever your volume base is, could be machine hours, could be labor hours, could be units. So if you deviate from your original plan, from your original base, this variance is called the volume variance. It could be favorable and adverse. So let us discuss these in detail to explain our understanding. Now, how do we calculate the spending variance? Spending variance is simply how much you should have spent as per our budget, what you should have spent, and what was the actual cost. It's very, very simple and straightforward. As per our original budget, let's say our fixed cost should have been $100,000 rent, insurance, and all the fixed costs. But our actual fixed cost, maybe it's 110. In that case, it is 10,000 adverse, negative. Or maybe it's just 90,000. As per the budget was 100, so it's going to be then 10,000 favorable. So basically, the spending variance will determine what was our original budget for fixed cost and what was the actual cost we incurred. The difference could either be a favorable or an adverse variance. It's very straightforward, very simple to calculate. We'll do all these in big questions. This one is little twisted, little confusing to some students. This variance is sometimes misunderstood by students. Let me explain this, and we are going to do some big questions that will involve all these variances, and I will explain how they work and how do we use them in variance calculations. Production volume variance is the deviation from what we originally planned for machine hours, for labor hours, or maybe for our units, and what we actually produced. So the formula that I'm going to rewrite so that it is more understandable. Standard hour allowed for actual output. This is the same thing, SQ. It's the same. SQ here is the same as the SQ here. They are the same. Standard quantity of hours that you should have used. Let me take you back to explain the idea. What basically it is. Let me show you and explain the idea to you well. Now look at this. You produce 8,000 units, right? As per our standard, you should use 3 hours for each unit. So if you produce 8,000 units and each unit should take 3 units, so 8,000 times 3, 24,000. You should have used 24,000 hours. This is called, I love this word, this is called the standard hour allowed for actual output. Just like this is the exact wording, let's not waste our time. Standard hours allowed for actual output. The actual output that we produce 8,000 units, right? We produce 8,000 units. So those 8,000 units, they should consume 3 hours each, which means we should have used 24,000 labor hours. This 24,000 will come here. These 24,000 hours are called the standard hours that you should have used for your actual 8,000 units of output, right? So that is simply SQ. Just put it with, this is SQ, nothing else. This is the SQ. Now, just I told you that SP here in the variable overhead, this SP is the variable overhead rate, absorption rate or recovery rate or allocation rate, whatever you want to call it. Right here, this standard rate is the fixed overhead absorption rate. Please remember, SP here is the variable overhead absorption rate. We discussed this in our absorption costing. And here, the standard rate here is the fixed overhead absorption rate or fixed overhead allocation rate, right? So what you're going to do, you're going to multiply your standard quantity with the fixed overhead rate, and from that, you're going to deduct your flexible budget. I'm going to explain all these in a big question where you will see the application of all these 4 formulas one by one. Let me show you a good example. Gentlemen, this is a wonderful question. And if you can understand this question well, consider your variable and fixed overhead variances are properly understood. Let's do this question in detail because there are many parts to it. Let me show you how many parts are there. Look at this. 1, 2, 3, 4, 5. 5 parts are to this question, which means it's pretty long and it will ask questions from different aspects. So let's read it first fully. Nando's companies manufactures a line of products distributed nationally through wholesalers. Fine. Presented below are planned manufacturing data for the year and actual data for November. You have the annual data given here, planned annual data, and this is the plan for November. So this is the annual plan, and this is for the month of November plan. This is the fixed overhead, variable overhead, direct labors we supposed to use, and machine hours we were supposed to use. On annual basis, this is on monthly basis. All right. The company applies overhead based on the planned machine hour. Our basis or our activity driver is the machine hour. I hope you remember when you calculate the fixed overhead absorption rate. For that rate, we need a driver, a denominator, a base. Let me show you what I mean. Let's say if you want to calculate the fixed overhead rate, we know the formula is fixed overhead budgeted divided by, in some cases, we may have machine hours, or in some cases, we may have labor hours, and in some cases, we might have units of output. In this question says that you will have to use your machine hour as a denominator. So it means the denominator, the base would be machine hour. So the company applies overheads based upon the planned machine hours using predetermined annual rate. Right. So what it means is that the machine hour right here would be our denominator, our basis to calculate the question. Okay. What the question says, we have been given the annual data for the whole year, also for the month of November, and we have also been given the actual data for November, actual labor hours used, labor hours that you should have used, actual machine hours versus the machine hours that we should have used, the actual fixed cost, the actual variable cost. All what we need for the overhead variances is given. Here it says the predetermined overhead application rate. Now this is interesting. The question says the predetermined overhead application rate or overhead allocation rate. He doesn't say fixed, he doesn't say variable. Mafi. No fixed or variable. That means he's talking about a single combined rate for fixed and variable. So if fixed and variable are combined for the whole year, the company applies overhead based upon planned machine hours using a predetermined annual rate. So what we do, we estimate what is going to be our annual cost of variable overheads and directly and the fixed overheads. So you can see that the annual cost for the coming period is expected to be 1.2 million plus 2.4, 3.6 million. This is the overall total overhead budgeted, combined fixed and variable both. And since I told you the denominator is going to be the machine hours, which means we are going to use this 240,000 as our driver, as our denominator. Right. So if you divide 3.6 million, which is our combined overhead cost, variable and fixed combined, and we divide that with 240, it's going to be $15 per machine hour. This is the composite rate or combined rate or single rate of variable and fixed combined, and that makes D to be the correct option. Right. So sometimes we calculate a single rate for variable and fixed both. Now it says that total amount of overhead applied to production. Total amount of overhead applied to production. It doesn't say fixed separately. It doesn't say variable separately. So what it means, what we calculated previously, what was the combined rate? I will call it the manufacturing overhead rate. Not fixed, not variable, combined. It was $15 per machine hour. This is the combined rate for the manufacturing variable and fixed. Okay. If this is the rate, we must find first the standard quantity that we should have used in November. Look at this. I'm not interested in labor hours. Why? Because the question is very clear. The question says that you should use machine hours. You should use machine hours, right? And I'm not going to take the actual machine hours, because remember, when we say standard quantity of machine hour, it means the machine hours that you should have used as per the standard, as per the original standard we said. So look at this. Machine hours actual. I don't need actual. I need machine hours planned based upon output. Whatever output you produce, you should have used these 21,000 hours. This is called the standard hours allowed for actual output. Whatever you produce, you should have used 21,000 machine hours. This is SQ. So we are going to write it as 21,000. Right. Now, our combined manufacturing rate, fixed and variable combined, is $15 per machine hour. Right. How many machine hours we should have used? We should have used 21,000 machine hours, which means our overhead estimated that goes into production is 15 multiplied by 21,000. That gives us 315,000. This is what you call the fixed and variable combined, the manufacturing overhead applied, or the total overhead applied. Total overhead, because he makes no distinction between the variable and the fixed part. Right? So that makes B to be the correct option. We haven't yet learned how to apply the formula right here. Okay, we'll come back to this question, because we need to learn the individual components. Under and over applied, I will tell you after we are done with this. Now, let us first calculate the variable overhead spending and the next fixed overhead volume variance. So let us calculate first the variable overhead spending variance. We know the formula. Let me show you. This is the formula. We're going to use the variable overhead spending variance is actual quantity into the variable overhead rate minus actual cost variable. So if you apply this formula, you can easily calculate the spending variance. Okay. Now, let me write down the formula here. We need to find the variable overhead spending variance, the formula for which is the actual quantity into the variable overhead rate minus actual cost. And which actual cost? The actual variable cost. Do we have the actual quantity of machine hours? Remember, our driver is machine hour. Actual quantity of machine hour is given right here. AQ, actual hours. SP, what is SP? SP is the variable overhead rate for the year. How do we calculate the variable overhead rate? The variable overhead rate is equal to the estimated variable overhead, which is 2.4 million, divided with the estimated driver, that is 240. So 2.4 million divided by 240, it gives you $10. So our variable overhead rate, or our standard price, or variable overhead absorption allocation, it's 10. So this is $10. Now we just plug in the numbers. Actual quantity of machine hours we used was 21,600. Multiply that with the rate we have for variable overhead is $10. So as per our calculation, 21,600 multiplied by 10. Our cost should have been 21,600 or 216,000 as per the standard. But our actual variable cost was 214,000. So the cost should have been 216,000, but the cost was only 214,000 as per the formula, which means our spending variance is 2,000 favorable, and that makes A to be the correct option, right? I've just used the formula, extracted the information, and here I go. Now, in this question, I have to calculate the fixed overhead volume variance. Fixed overhead volume variance, you have just learned with me. Fixed overhead volume variance is the standard hours allowed for actual output, which is SQ. Multiply it with the SP, that is the fixed overhead rate. Let us now calculate the fixed overhead rate. Previously, we divided 2.4 million variable with 240. Now, we are going to divide 1.2 million, the estimated fixed cost, with the estimated activity. That is 1.2 million divided by 240. So if you simplify, I guess you will get $15. This is your fixed overhead rate called SP in this formula. Standard quantity allowed for actual output multiplied by the standard price minus fixed overhead flexed. Fixed overhead budget or fixed overhead flex. Let me show you the formula so that you don't mess things up. This is it. Fixed overhead flexed. Flexible. I will explain what it means. Our annual plan for fixed overhead was 1.2 million. Fixed cost for the whole year was explained to be 1.2 million. Since we are talking only for the month of November, fixed cost can only be divided on monthly basis. So dividing 1.2 million with 12 gives you $100,000, which means the flex budget for November is 100,000 units. So if you just plug these in here, our standard quantity that we should have used is given right here. That for the actual output, we should have used 21,000. This is called the standard hours allowed for actual output, multiplied by the standard price, which is the fixed overhead absorption rate, that is $5. So as per the information, 21,000 multiplied by 5. Our fixed cost absorbed into production is 105,000. Right? This is what is absorbed in production. Minus what is the actual? What is the actual? Not actual. What is the flexed fixed cost? It is $100,000. So absorbed in production, allocated to production is 105. The budget was 100,000. So this is clearly 5,000 plus, and it is going to be a favorable budget. Let's press D. Right? D is the answer. Now let's say in the same question, this is the clearly the volume variance. Let us find out the spending variance, fixed overhead spending variance, which we learned the formula a little while ago. So fixed overhead spending variance, also called FS variance, is equal to what was the flex budget, fixed overhead monthly budget, minus fixed cost actual. Our fixed overhead budget was 100,000 for November. Remember, plan means budget. Our fixed overhead budget was 100,000, but our actual fixed cost, look at this. Our actual fixed cost is 101,200. So the difference will give you 1,200 adverse, 1,200 unfavorable. So yes, there is an option of 1,200 unfavorable, but this 1,200 unfavorable, this clearly is your spending variance, which is adverse. But in this question, we have to calculate the volume variance. So remember, the difference between absorbed overheads and the budgeted overheads, this gives us the volume variance, production volume variance, and the difference between the fixed budget and the fixed actual, this is called the spending variance, right? So A is the spending variance, which is not our answer, because A clearly, this is a favorable variance, and this is the spending variance. Our correct answer was 5,000, which is your production volume variance. Similarly, we can do the same thing here. In this question, we calculated, let us do some working again here for the variable overhead. Here we calculated our variable overhead spending variance to be favorable. Now let's, for the same question, let's say if we are required to calculate the variable overhead efficiency variance. How do we calculate efficiency? The standard quantity we should have used minus actual quantity we actually used multiplied by the standard price, that is the variable overhead rate. Standard quantity that we should have used is 21,000. Actual quantity of hours we actually used was 21,600. And the variable overhead rate we calculated previously in the question. Estimated variable for the whole year, estimated variable overhead for the whole year, and divide that with your estimated denominator level, that is 240. So in the previous question, we calculated this to be $10. So just put it in. We should have used 21,000 machine hours as per the standard. This is called the standard hours allowed for the output you produce. But the actual hours you used were 21,600. You used 600 hours more, multiplied by 10. So 21 less 21,600. So you have negative 600 here. Negative 600 into 10, you will get negative 6,000. So this negative 6,000 is your variable overhead efficiency variance, which is adverse and which is given here also. So this D option gives you the variable overhead efficiency variance, and which is given. I think this variance is favorable, and this variance that we've calculated, it is the variable overhead efficiency variance. So we have learned how to calculate the spending variance. What is AQ, SP, AC? We also learned how to calculate the efficiency variance, SQ, and we also learned how to calculate the spending variance for fixed overheads and production volumes. Again, let me revise. Spending variance is the difference between the fixed overhead budget. There is no division. You can just simply replace this. If you find this little confusing, you can simply write it the FOH budget minus FOH actual. What did you budget? What was the actual? This is called spending variance. And production volume variance is the standard quantity. Simply don't confuse with this. SQ is the standard quantity that you should use to produce your actual output, multiplied by the standard rate, that is the fixed overhead absorption rate, which I wrote as SP. This will give you how much fixed cost you have absorbed into our production. This absorption versus the flexed budget or just the fixed overhead budget, you can write it as FOH budget also. So this difference will give you the production volume variance. If it is positive, that means the volume variance is favorable. Negative means it's adverse. Right. Let's see a few questions further. Okay, sometimes you might be asked to do a question like this, where you have to calculate the total spending variance. We know total spending is made up of two types of spending variance. One is the fixed spending, other is the variable spending, right? When you say fixed spending, we know how to calculate. Fixed spending is the difference between the fixed budget minus fixed actual, right? And similarly, the variable spending is equal to actual quantity into standard price minus actual cost variable, right? And if we find these two results, we are going to simply add this up. So let us do this first one. Fixed spending variance, fixed budget, it is given. Fixed budget is 31,250. 31,250. Fixed actual, it is 33,750. Our budget was less, actual expense were more, so it is an adverse variance. 31,250 less 33,750. It is 2,500 adverse. So your fixed spending is 2,500 adverse. Let us do this for variable spending. AQSP, they are not given, rather we have been given the budget based upon the actual input. Actual input times the rate. We have been given this number straight away. So you will write it just here, 100,000. This is the AQ into SP net result minus actual cost 106. Now look at this. Our variable overhead should have been $100,000 as per the output achieved, but our actual variable cost was 106. This is again 6,000 adverse, right? 6,000 adverse here as well. So look at this now. This is 6,000 adverse. This is 2,500 adverse. If you combine these two, you should have a combined variance of both adverse. This one is adverse. This one is adverse, and combining these should give you a total adverse variance of 8,500. And I don't seem to have this number here. Okay, now look at this. There was a little mistake here in our computation. Let me rectify that mistake first. Here we should have written 106,250, which means it's going to be 100,000 less 106,250, which means it is negative. It is adverse 6,250. So 6,250 adverse here and 2,500 adverse here. Both combined adverse variances will give you 8,750. Total adverse variance is 8,750, and that should be your right answer. This is the total spending variance. So sometimes you can be given in bits, and sometimes you might be required to calculate the total this way. Total spending for fixed and spending for variable. Okay, now we have a comprehensive example which covers almost all the variances we have done so far. This question will ask you to calculate fixed overhead spending variance, variable overhead spending variance, direct labor price variance, variable efficiency variance, direct labor efficiency variance. See, many variances are involved, almost what we have done so far. So let us first read this question and analyze whatever we can extract and then find what is required. Water control system manufactures water pumps and uses standard cost system. The standard overhead cost per water pump are based on direct labor hours and are as follows. Variable overhead, it is applied at the rate of 4 hours at 8 per hour. This 8 is the variable overhead absorption rate or variable overhead recovery rate, allocation rate, many names. I just keep on saying it again and again. Fixed overhead is applied on 4 hours and the rate is $5 per hour. This is the fixed overhead allocation rate or absorption rate, right? So 32 for the variable, 8 times 4 and 5 into 4, 20 for fixed. Total overhead that goes into a single product is 52. Next line says here the asterisk sign here for $5 based on a capacity of 100,000 direct labor hours per month. This rate was calculated on an estimated 100 direct labor hours, which means in this question, the denominator or the base is the labor hours. Denominator is the labor hours. Sometimes it's machine hours, sometimes it's units, right? Okay, now, the following information is available for the month of November. 22,000 pumps were produced, although 25,000 had been scheduled for production. 94,000 direct labor hours were worked at a total cost of $940. Okay. The standard direct labor hour rate is $9. This is the rate we pay to our workers on per hour basis. Standard direct labor time per unit is 4 hours. Each item takes 4 hours of labor. Variable overhead actual cost is $740 and fixed overhead actual cost is $540. Right? Now, beautiful question, covers variances, labor, material, all. So let us now focus on the requirement of the question. Let's first erase it. So in this question, we need to calculate the fixed overhead spending variance for November. Fixed overhead spending variance. How do we calculate fixed overhead spending variance? Fixed overhead spending variance is simply the difference between fixed overhead budget and the fixed overhead actual. We don't have to be worried about fixed overhead actual. It is given right here. Fixed overhead cost were $540. This is actual. Straightforward, we can plug this in right here. But how do we calculate the fixed overhead budget? We have been given some information. If you use that information wisely, you can find it. Look at this. This is the fixed overhead rate, and this is the fixed overhead denominator level activity. We know how do we calculate the fixed overhead rate. Fixed overhead rate is equal to fixed overhead budget, and we divide fixed overhead budget with the activity, which in our question is given as 100,000 labor hours. Fixed overhead rate is also given, that is 5. So we have 5 is equal to fixed overhead budget divided by 100,000 units. So if you make fixed overhead budget as your subject, it is going to be $500,000. So this is your budget. Now look at this, gentlemen. Your fixed overhead budget was $500,000, but your actual fixed overhead was $540. You spent 40,000 more than the budget, which means it is an adverse variance, and that makes option D to be the right option. So if you go for it was a negative 40, it's A to be the correct option. Right. Now moving on to the next question. Now we have to calculate the variable overhead spending variance. We know the formula. And what we are going to do, we are going to first calculate the variable overhead rate. And if you just look at this, we have already been given spending variance. You know the formula, write it down. Variable overhead spending variance is the actual quantity multiplied by the variable overhead rate minus actual cost variable. We don't have to be worried about the actual variable cost. This is given right here. We have been given the standard price also. This is called the variable overhead rate or variable overhead absorption rate. It's 8 per hour right here. What we don't seem to have is the actual quantity of labor hours. If you just look at this, Look at this. These are the 9,400 direct labor hours were worked. Actual quantity of hours given right here. See? So you will plug in here 94,000 actual quantity. Okay, so I just need to bring what we did a little while ago, all the workings. So we have the actual hours worked, 94,000 direct labor hours. Our standard price is given here. The standard price is $8, that is the variable overhead rate, minus the actual cost variable, that is 740. Now let me explain what these numbers are. We have written these numbers where we need to make sense out of these. 94,000 times 8. 94,000 multiplied by 8. This is the variable overhead that should have been incurred. 752, right? As per the actual quantity of hours multiplied by the variable overhead rate. $752,000. But our actual cost was $740,000, which means our spending is 12,000 less than what it should be. So this 12,000 plus here is a favorable variance, and that perfectly matches with your option B. So if you click B, that should be the right option, right? A good question, looking at things from different aspects. Now we have to calculate the direct labor price variance, right? So we need to know the formula and then we can solve it. Direct labor price variance, what the price should have been versus what the price we actually paid. Let's bring this stuff in writing. So labor price variance is, or what you call the direct labor rate variance sometimes, is equal to what the price we should have paid versus what was the price we actually paid multiplied with the actual quantity of hours worked, right? Now look at this. The standard direct labor rate we pay to our worker is $9. Fine. But if you read this line above, right above this, it says 94,000 direct labor hours were worked at a total cost of $940,000. So $940,000 was the total labor cost for 94,000 labor hours, which means we paid at the rate of $10 per hour. This is the actual price we paid. Our standard price was $9, but the actual rate we paid was $10. So you can write it here. The standard price was 9, actual price paid was 10. How many hours were worked? 94,000 labor hours were worked. So you can see right here, 9 minus 1 into 94, it's going to be negative 94,000. So this is going to be your adverse. Labor rate variance or price variance is adverse, and it is going to be B. Now, let's do the same question. In the same question, let's say if you are required to calculate the labor efficiency variance, we know the labor efficiency variance is how many hours they should have worked minus how many hours did they actually work multiplied by the standard rate we pay to them, and standard rate is $9. We just saw that. So look at this. They have produced actual 22,000 final units, and as per the standard, each unit should take 4 hours. The standard direct labor time per unit is 4 hours. Each unit should take 4 hours. If you have produced 22,000 pumps, you should have taken 22,000 multiplied by 4. You should have taken 88,000 labor hours. But you took 94,000 labor hours, much above the standard. Multiply this with the rate, so you're going to get an adverse variance. 88,000 hours should have been worked, but 94,000 hours were worked multiplied by 9. So it's going to be 54,000 adverse. This 54,000 adverse is the labor efficiency variance, which is the option A. Of course, we are not doing for option A, but we just tried it. If you just see, this is the direct labor efficiency variance, 54, which is adverse, which we just calculated as our efficiency variance, right? So this is how you can do multiple questions from the same question. Now, in this question, we are required to calculate the variable overhead efficiency variance. We know the formula. Variable overhead efficiency variance is how many hours we should have used minus how many hours did we actually use for labor multiplied by the variable overhead rate. Remember, this SP here is the variable overhead rate, which is given right here, $8 per labor hour is the variable overhead rate per labor hour. We just saw that standard hours that we should have used of labor hours 88,000, but the actual labor hours we used were 94,000 multiplied by the variable overhead rate, that is 8. If you simplify this, 88,000 minus 94,000 multiplied by 8, so it's going to be negative 48. So your, interestingly, this is already circled. So your minus 48,000 is the labor or variable overhead efficiency variance. Now, in the same question, if we just twist this around, if we say, okay, now let us find out variable overhead spending variance, right? How to find spending variance? Spending variance is equal to actual quantity of hours worked multiplied by the variable overhead absorption rate, also called the standard price, minus actual cost variable. This is how we can find spending variance. So our result is there. 48 is our final answer, but we are just trying to play with the question. Actual quantity of hours that we worked was 94,000 labor hours. Standard price, which you call the variable overhead rate, it's 8, which means our overhead, variable overhead should have been 94 multiplied by 8. Our variable overhead should have been 752,000. But our actual variable overhead was 740. See, so our spending should have been 752, but the spending was 12,000 more. Our spending should have been 752, but we spent less, which means we saved 12,000. So this 12,000 is favorable. That is not needed here. So right now we just need to find out the variable overhead efficiency variance, and that is given as 48. So we have done all these. We have done variable spending, variable efficiency. We have done fixed spending, fixed efficiency, and also we did a comprehensive example which involved some material and labor variances as well as the overhead variances.